Hello and welcome back. We are continuing our conversation of our savings plan formula in the finance section of this course. We have previously learned about the saving plan formula, in which if we have a regular payment that we make into an account that compounds over a certain amount of time, we can solve for how much money we'll have in the future. Now let's do this problem. Find the monthly payment needed to save $6,000 for a down payment. So I want $6,000 in the future. This will be my future value. This will be the down payment for a car, an investment account that pays 5.5% interest. So this written as a decimal will be 0.055. Compounded monthly. So this will be little n equals 12. And then our time is 2 years. Now, if I use the saving plan formula, I have the FV. So this will be 6,000 equals the payment. And the payment is what I'm solving for because this says find the monthly payment. All times 1 plus the rate over little n, which in this case is 12, raised to little n, which is 12, times time, which is 2 for 2 years, minus 1. And all of this will go over a denominator of 0.055 all over 12. Now for this problem, we need to solve for payment. This can be done. It just creates a little bit of a calculator challenge. The way I would do it is I would do this whole calculation first. So everything in the numerator besides the payment divided by everything in the denominator, get that part all figured out. Whatever that is, then I would divide both sides by that to solve for payment. So this will take some fancy footwork in your calculator. If you have solved it correctly, you will have that the payment is going to be $237.07. This is solving for the payment required to reach our financial goal of $6,000. There is a second way for solving this problem, and that is to rewrite this savings plan formula in terms of payment. So what I want is payment on one side and everything else on the other side. Now, lucky for you, we already have that formula written out. This will be payment equals FV times the rate over little n, all divided by 1 plus the rate over little n raised to the n times t, all minus 1. This is the same formula we used up here, except for we're solving for a different variable. In the formula up here, when we used it in the previous video, we were solving for FV. Down here, we're solving for payment. They're the same formula. They are used in the same types of problems. It just depends on what we're solving for. So let's redo that problem using this formula. I will get payment equals our FV, which is 6,000, times the rate all over little n, which is the number of compoundings, divided by 1 plus the rate over 12, all raised to the 12 times 2 minus 1. Now everything is on one side of the equation. I just put in the calculator and I should get the exact same answer. If I don't get that exact same answer, then I've made an error along the way. So let's see this formula in action. You will graduate from college in 5 years. Your dream is to purchase a small franchise that will require an investment of $55,000. and you will open it in 5 years. Use the payment formula to answer the following questions about an account paying 3.7% compounded monthly. And to start part A, how much money should you deposit each month for the next 5 years? Okay, there's a lot going on in this problem. The first thing I would do is look at the problem and figure out what is being asked. Put yourself in the problem. So this is saying, I'm going to graduate from college in 5 years, and when I graduate in 5 years, I want to have $55,000. I have a goal of $55,000. So how am I going to get there? Okay, let's go through the values for the variables. First, we have 5 years. That's going to be our t. And we already decided 55,000 was the future value. Then we have the rate of 3.7%. So that's going to be 0.037. Compounded monthly, that will be n equals 12. So PMT equals 55,000 times 0.037 divided by 12. That's the numerator. And the denominator becomes 1 plus 0.037 over 12, all raised to the 12 times 5, then minus 1. If you put that in your calculator, you get $835.90. This is the amount that we will deposit every single month for 5 years to get to our goal of $55,000. For part B, how much of the $55,000 will you have deposited after 5 years? So in part A, we found the monthly payment. So that's $835.90. And this will be paid every month, so times 12 every month, for 5 years, so times 5. And if I multiply these together, the product will be $50,154. So this represents the amount of money that we actually deposited into the account every month. So we go to work, we save our money, and every month I'm taking $835.90 of that money and putting it into an account. So that's how we get to the $50,154. All right, for part C, we are asked to find the amount of interest earned. Just a reminder, we cannot use I equals PRT here because that formula is for simple interest, and we're not doing simple interest. So we put in our $50,154 into the account, and after 5 years, the account now has $55,000 in the account. So I will just subtract these two values to get $4,846 in interest that was earned.